CodeTether Radio, Episode 3, mDNS, Peer Discovery, and the Future of Local Agents. Welcome back to CodeTether Radio. This is Episode 3, and today we are going to stay on one topic, mDNS. Not as a random networking detail, not as an implementation footnote, but as a turning point in how agent systems become real systems. We're going to talk about the recent CodeTether pull requests that brought A2A into the 2E, then made peer discovery zero configuration, then connected that local discovery story to the bigger future of public, trustworthy agents. The thesis is simple. mDNS matters because the future of agents is not one giant chat box in one giant cloud. The future is many agents running near the work, finding each other, proving who they are, and collaborating without a human hand-wiring every connection.
The recent PR sequence tells a clean story. PR 111 exposed an A2A peer endpoint from inside the TUI. Before that, CodeTether had a headless spawn surface that could serve an agent card and answer JSON RPC calls. But the human-facing TUI was not itself a peer. That meant the thing you actually used all day was separate from the thing other agents could call. PR 111 collapsed that gap. The TUI could bind the same A2A surface, agent card at .wellknown/agent.json, JSON RPC on post/, a discovery loop, and automatic introduction. Two TUIs in two repos could now talk to each other. That matters because the development environment stops being a terminal island. Your interactive coding agent becomes a node on a network.
And the handshake matters because the future of software development is multi-agent. Not in the buzzword sense where 5 invisible bots all pretend to collaborate inside one model response. I mean actual separate processes with separate contexts, separate permissions, separate tools, and separate responsibilities. One agent should be able to ask another agent for the status of a work tree. One agent should be able to delegate a focused review. One agent should be able to discover that another agent is already working on a related module and avoid duplicate work. One agent should be able to say, I have a task. Who on this LAN is capable of helping? Static configuration does not scale to that world. A seed list is fine when there are 2 peers. It becomes friction when there are 5. It becomes brittle when ports change. It becomes a security hazard when stale endpoints linger. It becomes impossible when agents are ephemeral, when they come and go with 2 UI sessions, containers, test runs, or short-lived work trees. mDNS is built for that churn. It lets presence be announced and observed as an event stream. It fits ephemeral agents. The phrase default on is doing a lot of work in PR 118. Features that are technically present but opt in often do not shape behavior. Default on mDNS means the agent ecosystem begins forming automatically. Bare CodeTether launches the 2UI with auto spawn options. The 2UI A2A peer is on unless the user opts out with no-A2A. Spawn mode uses port 0, auto name, and mDNS unless disabled. This matters because discovery cannot become a cultural norm if it starts hidden behind a flag. The default defines the mental model. A CodeTether process is not merely a local assistant, it is a peer. There is also a product philosophy here. The best developer tools reduce ceremony at the boundary between intention and action. If you have to think about ports, your mind is pulled out of the work. If you have to coordinate 2 terminals by hand, you are doing orchestration labor that the system should absorb. If you have to remember which repo has which agent endpoint, the agent network is not really a network. It is a set of manual affordances. mDNS removes a layer of ceremony. It makes discovery ambient. Now, mDNS is not magic, and the PRs do not pretend it is. It is local network discovery. Multicast usually works on the same host or LAN. It often does not cross routers. It can be restricted by corporate networks, VPNs, container boundaries, Wi-Fi isolation, or firewall rules. That is why the legacy explicit seed polling loop remains. That is why PR 119, the documentation PR, talks about wide area discovery options. DNSSD in real zones, federation registries, and out-of-band card exchange. mDNS is not the entire future. It is the local substrate that teaches the system how peer discovery should feel. This is the central distinction. mDNS is the bootstrap for local agency, not the final answer for global trust. On a trusted LAN, it is reasonable for agents to find each other and auto-introduce. On the public web, discovery alone is dangerous. PR119 is important because it connects the transport and discovery story to identity and authorization. It says, now that agents can find each other, we need to make public agents trustworthy. The design composes A2A peer discovery with an agent provenance framework. It separates 4 layers: transport, discovery, identity, and authorization. That layering is the future. Transport is how messages move. Discovery is how agents find candidate peers. Identity is how a peer proves the card you received belongs to the agent you think you are talking to. Authorization is how the system decides whether a request is allowed, with provenance claims that describe origin, inputs, delegation, runtime, and output. mDNS handles the discovery layer for local networks. It should not be asked to solve identity. It should not be asked to solve trust. Its job is to make peers visible. Once visible, the rest of the stack can decide whether to talk, what to reveal, and what actions to permit. That is why the future is not mDNS alone. The future is mDNS plus signed agent cards, plus provenance tokens, plus policy checks, plus careful boundaries between local convenience and public exposure. But mDNS is still the spark. Without discovery, identity systems have no living network to protect. Without discovery, authorization gates wait in empty hallways. Without discovery, agent collaboration remains theoretical. The agent provenance framework design in PR119 introduces 5 dimensions that matter for public web agents. Origin asks where the request came from. Inputs ask what data influenced it. Delegation asks what chain of agents or users caused the action. Runtime asks what environment produced the behavior. Output asks what result was generated and how it should be treated. These dimensions become especially important once one agent calls another. If a local agent delegates to a public agent, or a public agent calls back into a local one, the system needs more than a bearer token. It needs a story for taint, accountability, and policy.
This is where mDNS and provenance complement each other. mDNS says, here is a peer nearby. Provenance says, here is what that peer is, who caused this request, what data is involved, and what policy should allow. The local network gives you immediacy. The provenance layer gives you safety. Together, they point toward a world where agents can self-organize without becoming a security disaster. Think about a normal developer workstation in the near future. You have the main CodeTether A2A in your product repo. You start another A2A in an infrastructure repo. A test watcher comes up in a container. A local documentation agent starts because you open docs. A browser automation agent is available for UI verification. Maybe a Kubernetes management agent is running in a terminal attached to a dev cluster. With mDNS, those processes can announce, I am here. This is my card. These are my skills. This is my URL. The main agent can discover them. It can decide which one to ask for help. It can coordinate. The environment becomes a living mesh. That mesh is the future, because software projects are no longer single context problems. A change touches Rust code, docs, tests, release notes, CI, deployment configuration, security policy, and sometimes a running browser. One context window is not enough. One process with one set of tools is not enough. Multi-agent systems are a natural response, but only if they can form connections dynamically. mDNS gives the first dynamic connection. PR111 brought the A2A into that world by giving it a peer endpoint. That is huge, because the A2A is not a background daemon. It is where the user is. If other agents can reach it, then the user's interactive session becomes part of the agent network. At the same time, inbound messages do not yet route directly into the user's live A2A conversation. The PR explicitly scopes that out. Inbound message send is answered by a fresh background session, like spawn mode. That restraint is good engineering.
It gives us peer reachability now without pretending the human-in-the-loop routing problem is solved. PR118 then makes that reachable TUI discoverable. This combination is what changes the default topology. A TUI is now both a client and a server. It can initiate work and receive work. It can discover and be discovered. That is the peer-to-peer idea in practical form, not a white paper, not a central dashboard, a terminal application that announces itself and answers messages.
There is something elegant about using DNS-SD service names for this. The service type CodeTether.A2A.TCP.local is a declaration that this is a real network service. It is not scraping process lists, it is not guessing ports, it is not relying on a hidden registry. It is participating in an established local discovery mechanism. That matters for interoperability. Even if CodeTether is the first consumer, the pattern is legible to network tools and to future agents. Service discovery is a protocol boundary. The implementation choice of pure Rust mDNS SD is also meaningful. No system dependency means the feature is easier to ship. A zero config feature that requires installing a platform-specific daemon loses some of its magic. Keeping it pure Rust aligns with the product promise. Launch the TUI and the peer exists. The less setup, the more likely the network forms. Let us talk about deduplication, because it sounds small, but it reveals maturity. Machines often have multiple interfaces: loopback, Wi-Fi, Ethernet, container bridges, VPN adapters. A naive mDNS browser might resolve the same peer multiple times. If every resolved URL triggered a separate discovery event and auto-introduction, the logs would be noisy, and the relationship graph would be wrong. Deduping by card name means one peer is one peer, even if it is reachable through multiple addresses. The implementation still records multiple URLs, but the human and the agent see a coherent identity. This is how discovery becomes calm instead of chaotic. Timeouts matter for the same reason. In a dynamic network, some peers will be slow, broken, sleeping, overloaded, or half gone. If the intake loop waits on one slow peer, discovery freezes. PR118 addresses that by spawning per-peer tasks with a 5-second timeout. That design says the network is unreliable, so the discovery loop must remain healthy. This is the kind of reliability detail that future agent fabrics need everywhere. One bad peer cannot stall the neighborhood. The auto-name design also points to the human side of agent networks. Names like short host, directory base name, short PID are not cryptographic identities. They are recognition handles. They let you look at logs and understand that is the agent in the backend repo on this machine. That is the one in the docs repo. That is the one in the temporary work tree. Good local naming makes a mesh understandable. Later, signed cards and provenance can provide stronger identity, but humans still need names they can read. Why is this the future? Because agent systems will increasingly be deployed as swarms of narrow capabilities, rather than one monolith. A code review agent may not need file system write access. A test agent may need shell access, but not secrets. A documentation agent may need docs and Git history. A deployment agent may need Kubernetes permissions. If each capability is a peer with its own boundary, then least privilege becomes natural. But those peers need to discover each other. mDNS lets the swarm assemble locally, without central orchestration. There is a parallel with microservices, but the scale and feel are different. Microservices often assume infrastructure. Service meshes, registries, load balancers, DNS zones, orchestration platforms. Local agents need a lighter weight version. They are closer to developer tools than backend services. They may live for minutes. They may run in terminals. They may be created by a user asking a task. They need discovery that matches that speed. mDNS is the lightweight local service mesh for agents. The future also involves edge and personal compute. Not every useful agent should be in the cloud. Some agents should run next to private code, local files, secure environments, hardware devices, or internal systems. A local network of agents can coordinate without shipping everything to a central service. That reduces latency. It reduces data exposure. It improves resilience.
It lets organizations keep sensitive workflows near the source. mDNS is a proven way for local services to find each other in that edge environment. At the same time, mDNS nudges us towards better UX for distributed systems. Developers should not need to understand distributed systems just to use distributed intelligence. The system should make good defaults: auto port, auto name, auto URL, default on discovery, opt-out flags for control, additive seed lists for advanced cases, clear docs, troubleshooting. This is the shape of a feature that respects both beginners and power users. The documentation work around A2A spawn also matters here. PR111 added a canonical guide covering 2 terminal walkthroughs, spawn and TUI variants, flag references, HTTP API details, peer discovery internals, bus registry, training S3 sync, authentication, model resolution, cross-host setup, curl recipes, Rust client examples, troubleshooting, and a source map. That is not just documentation for humans. It is a map of the system boundaries. In a future where agents call agents, documentation becomes operational infrastructure. An agent can read the guide, understand the endpoint, and use the protocol.
PR119 extends that documentation into the public agent future. It says local mDNS is the beginning, but once agents leave the LAN, you need signed identity and provenance-based authorization. This is a sober and important point. Discovery without trust is not enough. In fact, discovery without trust can be dangerous. A public network full of self-announced agents is an invitation to spoofing, prompt injection, data exfiltration, and confused deputy attacks. The future must keep the ease of mDNS while adding verifiable claims. This is why the phrase trustworthy public web agents matters. Public agents need to be reachable, but reachability is not permission. They need to advertise capabilities, but advertised capability is not proof. They need to accept requests, but every request carries a chain of origin and delegation. The agent provenance framework gives a vocabulary for that chain. CodeTether's mDNS work gives the concrete peer transport and local discovery experience. Together, they form a roadmap from LAN experiments to internet-scale agent collaboration. Let us ground this in a practical workflow. Imagine you are in the CodeTether repo and you ask your agent to investigate a bug in A2A discovery. The main TUI agent discovers another local agent running in a clean checkout. It asks that peer to reproduce. A third agent in a docs worktree checks whether the guide matches behavior. A fourth agent with browser or network inspection tools confirms an endpoint response. They do not need a central server to know each other exist. They use mDNS. The main agent can then aggregate findings, maybe ask the user before applying changes, and leave an audit trail. That is materially better than one agent doing everything sequentially. Now imagine the same pattern in a team environment. A shared lab network has agents attached to hardware devices, build machines, simulators, staging clusters, and code bases. When a developer joins the network, their local agent can discover what capabilities are available. The staging cluster agent can advertise itself. The simulator agent can advertise itself. The docs agent can advertise itself. Policy can decide who can call what. Provenance can record why. The result is an environment where capability is discoverable but governed. This is the future because agents are not just chat interfaces. They are network participants. They have cards, endpoints, capabilities, policies, histories, and responsibilities. mDNS is one of the 4 steps that makes that visible in CodeTether. It says an agent is a service. It can announce, it can browse, it can introduce itself. It can be part of a topology.
There is a subtle psychological shift, too. When agents discover each other automatically, users begin to expect collaboration. They stop thinking of the assistant as a single, isolated companion and start thinking of a workspace with multiple helpers. That expectation changes product design. The TUI can surface peer status. The system can show incoming and outgoing messages. The logs can tell a story of introductions and delegations. Tasks can be routed. Work can be split. The network becomes part of the interface. Of course, default on networking must be handled carefully. The PRs include opt-outs. No mDNS for spawn, no A2A for TUI. That is essential. Some environments will not want automatic peer surfaces. Some networks are hostile. Some users need silence. Good defaults are not the same as forced behavior. The future is automatic when safe, explicit when necessary, and policy-driven as the stakes rise. One reason mDNS is particularly appropriate at this stage is that it draws a clear trust boundary. .local is local. It encourages the implementation to treat LAN discovery as a convenience layer, not as a global registry. That keeps the design honest. For wide area discovery, the docs propose different mechanisms: DNS-SD in real zones, federation registry, or out-of-band card exchange. Those mechanisms can carry stronger identity expectations. The LAN can stay lightweight, while the public web gets stronger guardrails. This separation of local and public discovery is important for developer adoption. If the first version of agent networking required a full identity federation, signed cards, policy sidecars, and DNS configuration, almost nobody would feel the magic. If the first version only had mDNS with no future trust model, it would be a toy or a risk. CodeTether's recent PRs take the better path. Ship local discovery now, document the trust roadmap, and keep the layers orthogonal. The word orthogonal matters. Transport, discovery, identity, and authorization should not be tangled. You should be able to use mDNS for discovery and still require signed cards. You should be able to use a federation registry for discovery and still use the same A2A transport. You should be able to change policy engines without rewriting peer browsing. Orthogonality is what lets a local feature grow into a platform. This also aligns with the single responsibility philosophy in the codebase. The mDNS module should handle mDNS. Spawn should coordinate peer lifecycle. The TUI should expose the user-facing surface. Documentation should explain usage and design. Provenance should live in its verification layer. If each port has one job, the system can evolve. If discovery tries to become identity, or the TUI tries to own transport details, the architecture will fight the future.
The future of mDNS in CodeTether could include richer advertised metadata. Today, the service resolves peers and retrieves cards. Tomorrow, agents might advertise capability summaries, policy hints, version compatibility, or workspace scopes. But even then, the principle should remain. Advertise enough to discover and decide. Fetch the card for details. Verify identity when trust matters. And authorize before action. Discovery is the invitation, not the whole relationship. It is worth emphasizing how important auto-introduction is. Finding a peer is one thing. Sending an introduction makes the network social. It establishes a first contact. It lets logs show that two agents recognized each other. It can be extended later into richer handshakes, exchange signed cards, verify provenance support, negotiate capabilities, or decide whether inbound messages should route into a human-visible session. Auto-intro is the seed of protocol-level etiquette. But auto-intro also shows why public trust matters. On a LAN, a friendly hello is useful. On the internet, blind auto-intro could become noise or worse. That is why PR 119's design is not optional long-term. The future requires agents to know not just that another agent exists, but whether it is who it claims to be, whether its request chain is acceptable, and whether its output can be trusted. mDNS gets us to the door. Provenance decides whether to open it. Let us return to the phrase, mDNS is the future. More precisely, mDNS is the future of local agent bootstrapping. It is the pattern that lets agents become ambient infrastructure on a developer machine or LAN. It is the zero config layer that makes multi-agent collaboration feel natural. It is not the future because multicast packets are glamorous. It is the future because coordination without ceremony is the only way agent networks become usable. If every agent collaboration requires a user to copy URLs, pick ports, name processes, and maintain seed lists, multi-agent workflows will remain demos. If agents can appear, announce, discover, introduce, and coordinate, then the workflow becomes real. The recent CodeTether PRs move from manual topology to emergent topology. That is a major step. There is also a resilience argument. Central brokers are convenient, but they create dependency. If the broker is down, discovery fails. If the broker is slow, startup is slow.
If the broker is misconfigured, local peers cannot see each other, even when they are sitting on the same machine. mDNS lets local peers discover each other without that central point. It does not replace brokers for every scenario, but it gives the local fabric independence. For developer tools, that independence matters.
Security people may ask, does automatic discovery increase attack surface? The honest answer is yes. Any listening peer surface is an attack surface. That is why opt-out flags, binding behavior, local scope, auth plans, and provenance design matter. But avoiding discovery entirely is not a security strategy for a future where agents must collaborate. The better strategy is layered security. Limit scope, make identity verifiable, authorize actions, log events, propagate taint, and keep user control. mDNS is compatible with that strategy when treated as discovery only. The implementation detail of matching bound addresses to HTTP reachability is a good example of practical safety. If bound to loopback, announce loopback. If bound to 0.0.0.0 and address auto is enabled, publish a reachable non-loopback address. Do not advertise something peers cannot call. Do not overexpose when the server is only local. These are the details that align the network announcement with the actual security and reachability posture. Now, why talk about recent PRs in a podcast episode? Because PRs are where architectural futures become operational reality. It is easy to say agents should discover each other. It is harder to make the TUI serve an A2A endpoint, share code paths with spawn mode, bind correctly, generate usable names, announce via DNSSD, browse event streams, dedupe multi-homed peers, handle slow peers, keep seed polling additive, document the interface, and describe the public trust model. The recent PRs did that sequence. They turned an idea into a usable path. The most important takeaway is that mDNS changes the default assumption of CodeTether. A CodeTether agent is no longer only an assistant bound to one terminal. It is a discoverable peer in a local agent network. That means future features can build on peer presence. Peer lists, peer health, capability routing, delegation, shared task graphs, cross-repo coordination, human approval flows for inbound requests, provenance verification, public agent directories. The foundation is there because discovery is there. In a year, the most powerful agent workflows may look ordinary. You open a repo. The TUI starts. It finds the local test runner agent, the docs agent, the browser agent, and the staging agent. You ask for a feature. The main agent delegates review to one peer, reproduction to another, docs impact to another, and policy checks to another. You see the summary. You approve changes. The agents leave a trace. No one pasted a port. No one configured a broker. The workspace simply had an agent fabric. Think about a normal developer workstation in the near future. You have the main CodeTether TUI in your product repo. You start another TUI in an infrastructure repo. A test watcher comes up in a container. A local documentation agent starts because you open docs. A browser automation agent is available for UI verification. Maybe a Kubernetes management agent is running in a terminal attached to a dev cluster. With mDNS, those processes can announce, I am here, this is my card, these are my skills, this is my URL. The main agent can discover them. It can decide which one to ask for help. It can coordinate. The environment becomes a living mesh. That mesh is the future, because software projects are no longer single context problems. A change touches Rust code, docs, tests, release notes, CI, deployment configuration, security policy, and sometimes a running browser. One context window is not enough. One process with one set of tools is not enough. Multi-agent systems are a natural response, but only if they can form connections dynamically. mDNS gives the first dynamic connection. Before we close, it is worth naming the developer experience this creates in practical terms. The best infrastructure disappears until you need to inspect it. A developer should not have to know whether an agent chose port 43127 or 49208. They should not have to remember which repository is running which endpoint. They should see names, capabilities, and trust status. Underneath that clean interface, mDNS is doing the quiet work of presence. Presence is the beginning of collaboration. If an agent is present, it can be addressed. If it can be addressed, it can be asked for context. If it can be asked for context, it can be delegated to. And if delegation is backed by provenance, audit, and policy, then the system can grow without becoming reckless. This is also why the implementation should stay modular. Discovery should discover. Agent cards should describe. Provenance should authorize. The session layer should execute. The audit layer should record. The TUI should present the state clearly to the human. Keeping those responsibilities separate is not just clean code, it is a safety property. When discovery is mixed with authorization, or UI state is mixed with execution policy, systems become hard to reason about. CodeTether's recent direction is strongest when each layer does one thing and composes with the next. The most exciting future version is not a swarm that blindly does everything. It is a supervised network where each peer has a narrow job, clear permissions, and an inspectable history. A docs agent can be allowed to read repository summaries and write markdown. A CI agent can be allowed to read test output and suggest fixes. A release agent can be allowed to draft notes but not publish without approval. A security agent can be allowed to block unsafe delegation. Discovery makes those peers visible. Policy makes them safe. Provenance makes them accountable. That is the shape of mature agent software. Not one magical box, but many cooperating services with names, cards, capabilities, scopes, and records of what happened. In that world, mDNS is not the whole architecture. It is the doorbell. But a doorbell matters. It tells the network that someone has arrived. So the next time a CodeTether TUI starts, announces _CodeTether A2A.tcp.local, resolves another peer, fetches its card, and sends an introduction, remember what is really happening. A local development environment is becoming a distributed system, not the heavy, fragile kind that requires a platform team to operate, but a small, developer-owned mesh that can grow as the work grows. That is why this feature deserves attention. It is easy to ship a command line flag. It is harder to create a default behavior that nudges the whole product toward collaboration. mDNS discovery does that. It makes the first connection automatic, and every larger agent network begins with that first connection.